Yes, dear friend, in last video I introduced you with thermal conductivity and methods of transfer of heat. Now, where it is uh, playing some important role in our life, day-to-day life, means I have written applications of thermal conductivity. Actually, uh, in hot region, suppose in sun, a piece of iron and piece of wood are lying. When you touch, you feel iron much hotter than a piece of wood. In the sun, open somewhere in the sun, piece of wood and iron are lying. Iron in the sun. Now, when touch, you feel iron piece much hotter than wood piece, while both are at same temperature. Reason: wood is bad conductor of heat, iron good conductor. So due to that, when we touch it, heat starts flowing from other portion of the iron to our body. While wood is bad conductor, if we touch it here, only this region will give heat us. So no flow of heat will take place. Actually, we feel hotness or coldness when we are getting heat continuously. Temperature of our body increases and we feel hot. But if heat is lost by our body, we feel cold. Similarly, when the same two are in cold room, in winter season, a piece of wood and piece of iron are in the room. When you touch, iron is felt hot, while wood not like that. Why? Again, both are at same temperature. But naturally, temperature of the two same, but will be lower than our body in winter season. When we touch iron rod, it is good conductor. Take heat from our body. It does not take. So we feel iron as much colder than wood. Liquids and gases are poor conductor. Liquid water is bad conductor of heat. Gases again furthermore bad conductor of heat. Even metals have different conductivity. There is a table here in NCERT on page 287. Thermal conductivity of some material: silver 406 watt per meter per Kelvin, copper 385, aluminium 205, steel 50.2 only. Your kitchen wares like the pan in which we prepare tea, etc. The handle is of steel, and we don't feel it hot because its thermal conductivity is very much less than copper and silver. Only it is 50.2, while for brass it is 109, lead 34.7, mercury 8.3. So this way the conductivity of metals varies. Please write this table in your notebook. You prepare these notes from my videos. I'm getting good response from someone, but there are others which are commenting in bad way. They are harming themselves. Actually, if you you must take something positive from everywhere. The good things should be accepted. Now, similarly, non-metals. Concrete 0.8, body fat 0.2, felt 0.04. Felt means cotton which have been made by powder type, glass 0.8, ice 1.6, glass wood 0.04, water 0.8, like that. Gases are further more bad conductor. Air has conducted 0.024. They conduct but very poorly. That is why concrete, they're bad conductor, but in summer season, our building become hot and inside become hotter because conduction of heat takes place from outside to inside. To avoid the excess heating of the building, the concrete roof is treated with mud, soil, mitti, earth se. Because earth is bad conductor, soil is bad conductor of heat. So there are many example kitchenwares actually like aluminium. You see here aluminium has 205, conducted 205 for aluminium. While for copper 385. So generally some kitchenwares, the bottom are painted with copper. तो क्यों कर सर? बिकॉज ये जो है कंटेनर है हमारा ऐसा, तो इसका ये जो बॉटम है इस पर दे पेंट copper paint so that it conducts heat larger area, through larger heat conduction become easier. So there are many applications of this thermal conductivity. Now actually I want to come to next topic here. By every material has a limit to conductivity, and the limit to conductivity means the conduction of heat is also opposed, and that opposition is called thermal resistance. Thermal resistance. In classes, these topics are not taught, but in competitive exam questions are there. Thermal resistance. We know heat flowing per unit time through a conducting rod of length L and cross area A. When temperature difference to any theta 1 minus theta 1 and theta 2. Theta 1, theta 2 are temperature of 2 and so heat flowing per unit time Q by T is equal to Ka into theta 1 minus theta 2 upon L. In last video I have told you this thing. Heat flowing per unit time. थोड़ा सा अब हमें दूसरी साइड देखना होगा. Electric current you might have learned in class 10. Electric current, flow of charge. Flow of charge per unit time Q by T को हम I लिखते हैं. ओम्स लॉ कहता है V upon I equal to R, potential difference divided by current passing through conductive resistance. So we take the help of this. Here Q by T equal to heat flowing per unit time, and is called heat current divided by H. We denote it by H. So here H equal to, in place of Q by T, we can use H. Like I is the electric current, which is the flow of charge per unit time. It is the flow of heat per unit time. Ka into theta 1 minus theta 2 upon L. Here, like this potential difference V2 minus V1, theta 1 minus theta 2. Theta 1 minus theta 2 is the temperature difference. So, we can write here theta 1 minus theta 2 upon H is equal to L upon Ka. If we compare it to V2 minus V1 upon I equal to R by potential difference divided by current, Ohm's law, equal to resistance. So here theta 1 minus theta 2 upon H is called thermal resistance. थर्मल रेजिस्टेंस, इसको हम आर लिख देंगे, आर। तो आर इक्वल टू हियर एल अपॉन के ए। I have seen many questions in NEET exam, JEE on question, because in classroom this topic is not taught this way. What the unit? Do you have learnt unit of K? Watt per meter per Kelvin. So it is L meter upon watt per meter per Kelvin, and A is the meter square. So what is this? ये मीटर कैंसिल हो गए. It is left unit of thermal resistance. Is equal to Kelvin per watt by meter. -1 + 2 + 1 हो गया, m कैंसिल. तो it is Kelvin per watt. Remember it. Thermal resistance है यूनिट क्या भाई? Kelvin per watt. Now actually time bound program create lot of trouble. Here I have written H यानी कि Q by T, heat variable Ka into theta 1 minus theta 2 upon L. Here theta 2 minus theta 1 minus upon L is called temperature gradient. Temperature gradient means variation of temperature distance. But when we are hitting one end of road, the other end also heating is being hitting, but temperature of that in contact with source of heat is higher than, and that difference per unit length, temperature difference per unit length is called temperature gradient. Minus negative sign indicates that temperature decreases as we move away from source of heat. Now listen one thing here. If we assume that there is no loss from the sides, but heat flows this way, actually loss of heat will take place by convection and radiation also. Every hot body radiates heat in the form of electromagnetic waves, which are called infrared radiation, and transfer heat. If there is no loss from the sides, if there is no loss of heat or we neglect this loss, then there is no loss of heat from sides, from sides of road. Then temperature gradient, temperature coefficient will be constant. मतलब हमने यहाँ ये लिया और या ये लिया या ये लिया, कहीं दिन सेम है, लेकिन अगर हीट लॉस नेग्लिजिबल नहीं है तो टेम्परेचर कोएफिशिएंट डिफरेंट है डिफरेंट प्लेस. If loss of heat is not negligible, loss of heat by the sides is not negligible, then temperature coefficient, temperature gradient will be changing. From one segment to another. There are many things based on conductivity. The new quilt or our cotton clothes, new cotton clothes are good in summer, in winter season. They save us from loss of heat of our body and we don't feel cold. But when they become old, they become little conductor of heat and don't protect from cold as new one. Why? The cotton cloth or quilt जान लिहाज से कहते हैं cotton से बना हुआ. There is air between the different parts. There is large sufficient air gap. Air is bad conductor, so heat does not enter the body. But when it become old one, the particles of cotton come close to that and air comes out. So the column of thickness of air column becomes small and start conductivity. So good conductor generally metals हैं, not है ना. Some good plastic are bad conductor, liquids are bad conductor, air is bad conductor, water is bad conductor. बताऊँ आप, तो I will take next in next